Hello to all. Today I'll tell you about another important part of blockchain algorithm, a digital signature. Digital signature is extremely important. All the security of our cryptocurrency transaction is based on a digital signature. It's very widely used in all modern informational security algorithms. A digital signature is a way to prove your ownership on some address in Bitcoin, Ethereum, or any other blockchain. Any decentralized network use the digital signature is a way to prove the ownership on some informational resource. The first concept we must understand a digital signature is the key pairs and asymmetric cryptography. In a traditional crypto system, we had two sides, Alice and Bob, and they had the same secret information, call it the key. They used that key to encrypt and decrypt the information. I'll denote the open message as a M, a key as a K. Then Alice make an encryption using her secret key and receive the ciphertext where the information is hidden. Then she transfers the information through the network, through the unsecure network, where a hacker can sniff every part, every data. And Alice wants to hide its open message in the encrypted message. Then Bob uses his secret key to decrypt the ciphertext to receive the open message. This is the scheme of traditional symmetric cryptography. In the asymmetric cryptography, the principle is to use two keys for each participant. Okay, let's go into it. With the asymmetric cryptography, the situation is different. Each participant has two keys. In the same situation, Alice has a key pair, so-called key pair, a pair of keys. I'll denote it as P and S. The P is a public key and S as a secret key. Secret. Okay. Bob also has its key pair, the public key of Bob and secret key of Bob. It will use it in the informational exchange between Alice and Bob. The first scheme we need to understand is the secret transfer of information. In the asymmetric cryptography, the roles of these two keys are different. For example, if one key is used for encryption, then secondary key use it for decryption. And vice versa. For example, if the public key is used for decryption, the secret key can be used for encryption. With such roles of the keys, we can organize an information exchange like this. Alice tells Bob, "Bob, here is my public key. Please encrypt all information for me with my public key." And Bob sent all data to Alice encrypted by her public key. I denote it so. Now nobody can read the data because nobody has a secret key. Nobody can can calculate the secret key from public key. But the inverted operation is very simple. Everybody can receive a public key from the secret key. Alice wanted to send Bob also the data. Bob can send to Alice a public key, his public key, and Alice also can send a data to Bob encrypted by his public key. This is the scheme of secure information transfer, but we will go further. We will change the roles of the keys and use it to make a digital signature for some arbitrary data. The algorithm of digital signature is slightly different because we have another goal. we don't need to hide the message. We just want to prove everybody about the fact that we've seen this data and we agree to each bit of it. The first, we must remember what is hashing algorithm that we've talked about in another video. I have some file, and for example, it's some contract in the Microsoft Word file, and I want to prove that I've seen this file without changing any bit of it, and I want to add something to this file, call it a signature, that can prove that I've signed this file. How I can do it? My name is Sergey, and I have my own key pair. I have a public key of Sergey, and I have a secret key of Sergey. In the digital signature, to sign some file, I need to do a simple set of actions. The first, I take my file and I calculate the cryptographic hash of it. You already know what is the hash. The secondary, I encrypt my hash with my secret key. This is different with the previous scheme. In previous scheme, we were encrypting the data with the public key. For example, sending the data to Bob, we encrypt the data for Bob with Bob's public key. Here, I encrypt my hash with my secret key, and it's important. I use the secret key for encryption. It's strange, but I'll explain it later why we are doing so. And this encrypted hash I call the digital signature. This is my signature, made by my Sergey's secret key. This was the procedure of generating a signature. The second part is the checking of signature. You need three parts to check my signature. The first is the file by itself. So you just download it from the internet, for example. Also, of course, you need my signature. And the third, a very important part is my public key. So you need my public key to check the signature, the public key of Sergey. What are you doing next? To check the signature, I perform the following steps. I take the signature, I decrypt it using the public key. You decrypt the signature using my public key. And you should receive the same hash I've calculated here. But it can be broken if something is broken in the incoming data. For example, something broken in the file, something broken in the signature. Maybe I choose the wrong public key. So to check the errors, I calculate the hash of the file by myself, using the algorithm we've spoken about in another video, and we just compare these two values. If they are equal, then signature is valid, because only the person who knows the secret key of mine can generate such a signature that decrypted with my public key equals the exact hash of the file. If these two values are not equal, then something is broken. But I can say what is broken. I can say I can differ the cases when the file was changed, the signature was changed, the public key is wrong. I just compare these two values. This is the basic scheme of generation and checking the digital signature. Of course, you can sign almost any kind of data. You can sign a short message or a huge file size with many gigabytes. It doesn't matter. Okay, how the digital signature is used in the decentralized network? In the decentralized network, with no central authority, there is no way to have a kind of accounts like an accounts on the websites, and every node can be turned off, and any other node can take its place. So we cannot differ these two nodes. The only way to differ the transaction from the same address is to use the digital signature. So every node in every decentralized network, in every blockchain, Bitcoin, Ethereum, or any other blockchain, has its own key pair. For example, the node number 3 have a key pair number 3. The node number 4 have a key pair number 4. So every transaction from this node must be signed with the secret key of the third node. Any other node who wants to forge the transaction of the third node must know its secret key, but it's not possible. And every node in the network can generate any amount of key pairs. You can change it in every moment. And these public keys of nodes are the addresses in the network. It's very useful because every node has the address constructed from its public key, and the same public key is used to sign the transaction. For example, if we're talking about, for example, a Bitcoin transaction, in simple words, we can talk about it like about a small file in which we store the information about how much Bitcoins we want, from which address we want to spend the Bitcoins, to address where we want to transfer our Bitcoins. Also, we fix the commission for the miners, and then we add the signature that proof that we have the ownership of the address from which the Bitcoins are transferred. The digital signature is very important in the decentralized world. Almost every transaction transferring cryptocurrency, currencies or calling the smart contracts is signed by your private keys. So you must be always sure where your private key is. Okay, we'll talk about another algorithms in decentralized world in the next video. See ya.